Can you believe it? Last whiteboard review. This is 27th is Monday. We have Monday and Wednesday in this same review. So the first thing he did, we talked about small businesses. We gave some examples. There are a lot of small businesses that are going to need some type of network. So they need technology. Like what technology needs? They might have probably have a website, maybe Wi-Fi, public and private in their business. Are they going to run their own email services? They probably need email, but are they going to run their own? They're going to buy servers for the website, for file transfer. Maybe they're going to run their own database, assign IP addresses to the computers. Are they going to run their own DNS? Okay. We talked about what kind of devices: PCs, laptops, tablets, personal devices, all these different things that do compute. Okay, so we might call them a host or an end device, all these things that connect into the network. And we talked about the network topology. Physically, how things are going to connect, and logically, how they connect. And then later on, we'll talk about addressing. Are you going to build redundancy in the network? So if one device goes down, another device takes over. Traffic management. What kind of traffic are you going to have? You're going to be running voice over IP phones. There's going to be a lot of data transfer, not much, and like who's getting what data, how are you going to manage all that? We talked a little bit about quality of service, giving priority to voice over IP. And in doing that, we can create VLANs to run certain traffic on separate VLANs, and VLANs are really separate networks. Talking about scaling, can you grow? And is it easy to shrink your network? What ports and so forth. A lot of things to consider even in a small business network. Network equipment, we talked about a switch, a router, access points. I asked how much to buy a device that's all these or these, maybe separately. Yeah, this looks like a range, $50 to $5,000 for a small business. Instead of a router, sometimes business will have a firewall. I gave the example of a business that had a firewall that connected out to the internet, and then off the firewall they connected 2 access points. And that took care of most of their connectivity needs within the business. Okay, so we have a need for, let me use another color here. So we have a need for technology. We know we're going to have end devices connected in. And then what else we need then? Network equipment, right? And then nowadays, most devices need access out. So they need an ISP. And then there, you can talk about addressing, and you can actually purchase a public IP. So as in the green, we got the key things that would be part of the network. And we talked about how you lay it out and so forth. So then we did a little searching, and we came up with some prices for Mediacom, different business packages, WCTA, CenturyLink, and we talked about your download speeds are typically way greater than your upload speeds measured by bandwidth. And there are some examples here, of bandwidth and how much they cost and so forth. Okay? Now, these plans will measure bits per second, right? And you pay bits per second, and some will measure the quantity of data, like bytes, the quantity of data that you're also transmitting, and limit you there, possibly. Still Monday. We did a skills project with the switches and the routers. But before I get to that addressing, the packet tracers, you need to finish those up, and there is a skills packet tracer, the final. You need to have that taken. Okay, that's in with the skills work, so that has a relatively significant impact on your total results. Okay, grade-wise. So we have this address, and we did this before, and in our scenario here, I was saying, well, we need at least 8 networks with 30 addresses on each of those. So the students came up with dividing it right here, and so this part, I'll do it in green. From here on, those 8 bits would give us, those 3 bits will give us 8 networks. Corrected. 3 bits. And so that'd be the next network part. And yeah, let's show that here in the red. Right? From there to there, the network part. And then in blue here, we have 5 bits, which would give us 32 total combinations, which then would be 30 usable addresses. Then we have this scenario where the students, we assign them a switch and a router, and then they went in and made the adjustments. Now, here we did the networking. Okay, it'd be a /27, right? Here would be 24, and then we borrowed 3 bits. 24, 25, 26, 27, right? You got 8 bits, 8 bits, 8 bits, and 3 more. And all the rest of that would be host. Or interfaces, depending on how you want to word that. So it's a /27, so this was our first address range, right? 1 to 30, because our next network would be 32. That would be, if you were looking at here, that would be this one, 001, one group of, and that's 32. Right there, that. So it's 32. So the first address, I've got an error here, let me correct it. The first address would be 33, right? First address 33 to 62. Surprised the student didn't catch that. 3362. I should have got it. Then 63 would be the broadcast. 64 is the next network. 65 to 94. 95 would be the broadcast. 96 is the next network. So we have all of these networks. Now we had the scenario where we wanted to have these 5 servers, but we don't want to waste any addresses, so we don't want to use a group of 30. So we took one group here, which was this one, okay, 224, 111, and then here in the green, we subnetted it again. Now we have 4 networks that would give us 6 addresses each. So that would work for 5 servers. right? 6 addresses. They give us, I should go through that. We got 3 here. I'm going to use that color. So we got these 3. 2 to the third is 8 total. Then we have the network and the broadcast, so we have 6 left over. So that would satisfy 5 servers and then 1 to connect back into the network, the interface on the router. Then the students did some loopbacks for this. Well, the new address, see that's the address we took, and then here's the new address /29, right? 20 would be 8, 8, 8, 8, so that's 24, 25, 26, 27, 28, 29. So the prefix bits, 29. I'm going to keep moving. We talked a little bit about troubleshooting. You know, we talked about somebody says, I can't get to the internet. And so, talked about the OSI model. First thing, anytime troubleshooting, make sure you understand the problem. You have to know, understand what the problem, and then you can start looking at solutions. And if it doesn't look like it's clear, then most people say, if you're a little bit inexperienced, you start and say, could it be a physical issue? Could something be unhooked? Okay. Could it be the connection in to the network, the data link? You could go in and look in the switch. Is there a MAC address in the switch for the PC? If there isn't, one that matches up the port, well then the problem is somewhere down below here. Then you can look at the network layer and check all the IP addressing. Right? Places that go wrong, mistyped or miscalculated subnet mask, a typo in the IP address, using a network, or, well, typically they won't let you put in an inappropriate address unless you put one in a wrong network and, it doesn't match the network you're actually on. Okay. So we talked a little bit about the ICN was doing some work on their network. And I mentioned one time they had issues with this router, so they were going to reboot it. And somebody said, well, they're rebooting the internet. Now they're rebooting the access to the internet. So it's the 29th. This was Wednesday. We talked about Brian Powers speaking on Thursday. I might have to use a different color here. Try blue. Brian Powers speaking on Thursday. Jim Deegan is going to speak on network security. Excuse me. On I don't have the virus, by the way. I don't think. Of course, you never know for sure. So Thursday, Brian spoke. It's already over. So about 15 minutes present, and then we went actually about 40 minutes. So it was really good. Talk about finishing your packet tracer, and we talk about the next course. Okay, we're going to learn about VLANs. We talked about this idea you can have an access point, and you can have the staff coming in on one IP address, the students being on another IP address, and then between here, this can be a trunk, so it can carry tags the traffic as it moves, and then that traffic can be put on the right VLAN when it gets to this device. So you can actually, you can actually sort that traffic out. So maybe this traffic goes this way and this traffic goes this way. So that's what we're going to learn all about that. We're going to learn about ether channel, the idea you can group together a bunch of ports and make a channel so it's a lot more bandwidth to send traffic through. Redundancy protocol, the concept you can have a virtual default gateway so that PCs here be going this way and PC here, the yellow, maybe they're going this way, and then if for some reason this connection goes bad, now these can just go this way and it automatically switches over. Wireless LAN, we're going to talk about wireless, and then routing. We'll also add network address translation, NAT. We'll talk a little bit about that before the summer's over. Talk a little bit about firewalls, access control lists, a couple things like that. And then we talked about one more time this. Talked about grades. If you have questions on that, you need to let me know. I filled in zeros so you could see what your grade would be, and you need to take care of that. We talked about some general stuff, debug. This was actually the first slide, and the one I went over was actually the second, but we talked about debugging, making sure you turn it off, real performance hit, but really handy to debug, especially looking at specific things you might be debugging. We talked about that addressing, command line interface, getting used to managing, configuring routers and addressing from the command line. Understanding IP addressing is so important, and then understanding the whole concept of subnetting. Scaling networks. We did a little bit of practice with ARP, address resolution protocol. Looking at that tie between the MAC and the IP. We logged in the work server too, access the equipment, tell them that. And then we talked about the addressing project. So the students went in and looked at, some of the examples. Some of them had it working and so forth. Talked about the public address here. So inside the switch here, we've got, for an example, this address pointing, let's say, down here. Now this router can split up with this octet, can split that up any way it wants to, and we did the addressing on in the other example. So we put loopbacks in there to represent these other networks, and then we had a network here set up where we could have 30 addresses. Now we put an address in the switch, so it wouldn't be 29, and then we have the address here at the router, so actually 28. 28 is what we had. So we took a look at routing and IP addressing, in this example in which we use the network we had already configured. This router up here, it sends the 172.21s that way, and it sends the 192.168s that way. So a good example would be we could put some loopbacks in there with another set of IP addresses. Remember, the only way to move from one network to another is to have it routed. One last thing, we talked a little bit about this address here came from our ISP. So out on the internet, there's certain parts of this that indicates that it's in the Americas, Aaron. And then, once it gets there, then it goes to the ICN, and then the ICN sends it to NIAC, and then NIAC splits it up and gives parts of it to our IT program, and then our other parts go to the main campus. Okay, and that wraps up the year, period.